Today, we are going to introduce Sniper biases principle. There are three parts. Part 1, biases analyze principle. Part 2, biases analyze history. Part 3, ISE analyze principle. Part 1, biases analyze principle. In the spectrum, the wavelength of visible light is from 400 to 760 nanometers. Absorbance. The absorbance is a measure of the quantity of light absorbed by a sample. Usually, the y-axis of a spectrum is defined as follows. I0, the intensity of the light entering the sample. I, the intensity of the light leaving the sample. The less light gets through, the great absorbance. Absorbance curve. The wavelength of maximum absorbance is called delta max. For the best accuracy, when measuring the absorbance of several substances, it is the best to measure as close to delta max as possible. The same substance with different concentrations has similar absorbance curves and the same delta max. You can see two substances. Which of these two substances will have a higher absorbance at delta max? The deeper color, the greater absorbance. Different substances have different absorbance curve and delta max. There are two measuring principles: calorimetry, Lambert-Beer law; turbidimetry, antigen-antibody reaction. First, Lambert-Beer law. This is the equation of Lambert-Beer law. A. Absorbance. I0. Incident light intensity. I. Transmission light intensity. Epsilon. Absorptivity of the substance. L. Light path of the solution in centimeter. C. Concentration of the substance. The prerequisites for turbidimetry: number 1. The absorbed light is monochromatic and parallel. Number 2. The solution is homogeneous. Here is turbidimetry. There are two kinds of turbidimetry. Transmission turbidimetry, for granular size near the wavelength. Scattering turbidimetry, granular size less than wavelength. Turbidimetry can be divided into transmission turbidimetry and scattering turbidimetry. Transmission turbidimetry was applied by Snipe. Like most special protein, apolipoprotein AI, apolipoprotein B, apolipoprotein E, alexin, C3, C4, immunoglobulin, IgG, IgM are tested by turbidimetry. Turbidimetry is similar to Lambert-Beer law. The prerequisites for turbidimetry: number 1, the observed light is monochromatic and parallel. Number 2, no settlement occurs in the test solution. So for measuring technology, pre-spectral photometry, post-spectral photometry. So for pre-spectral photometry, the white light gets through the wavelength selector. Then the incident light will get through the solution. The detector will detect the transmitted light. Post-spectral photometry. Post-spectral photometry is applied by so the light will get through the cuvette first, then the wavelength selector, then detector. Part 2. Biases Analyzer History. What is biases analyzer? The clinical biochemistry analyzer is an instrument that uses the pale yellow supernatant portion of centrifuged blood sample or an urine sample, and includes reactions using reagents to measure various components, such as sugar, cholesterol, protein, enzyme. Biochemistry tests are performed for routine health checks or at hospitals, and the results provide objective data enabling early detection and diagnosis of disease, as well as indicating the effects of treatment and patient prognosis. So there are semi-automatic analyzer and fully automatic analyzer. Sniper biases analyzers have different throughput to meet different requests. We have small size, intermediate size, and large size. In the structure principle, there are flow systems, discrete systems, centrifuge systems, and dry type. The first biases generation is called spectrophotometer. The advantages of this analyzer is reading the absorbance directly, easy operation, cheap reagents. And the disadvantages, it can't get sample results directly, operation error, few test items are available. The second generation, semi-automatic analyzer. Some procedures, sampling or reporting and calculating sample results need to be operated manually. Others are operated by the analyzer automatically. And its advantages, compact design, flexible, can be used separately, and can be used with other instruments, cheap, directly calculate the concentration, monitor the absorbance real time. But the disadvantage is sampling manually, incubation outside the analyzer which causes errors. The third generation, fully automatic analyzer. All procedures including sampling or reporting and calculating sample results are operated by the analyzer automatically. Technician company in America successfully produced the world's first automatic biochemical analyzer. It can be divided into discontinuous systems, discrete systems, centrifugal systems, and so on according to the structure principles. The advantages: tests are finished by the analyzer automatically without any manual operation, less operation errors and influence factors, fast. Sniper biases series are fully automatic. Flow systems. The continuous stream of liquid samples and reagents are combined and transported into tubing and mixing coils. The tubing passes the sample from one apparatus to the other with each apparatus performing different functions, such as distillation, dialysis, extraction, ion exchange, heating, incubation, and subsequent recording of a signal. Flow systems can be subdivided according to 1. The interruption of the stream by gas segments, liquid segments, or both. Number 2. Transport rhythm, continuous or discontinuous systems. Number 3. The way the specimen is introduced to the system, respiration or injection. And its disadvantages are slow speed, can only test one sample one time, one pipe for one assay normally. The discrete systems. The only common characteristic is discrete sample processing, which involves transport of the sample or reaction mixture within an individual container. The first one is launched in 1964. And its advantages are running multiple tests on one sample at one time, or multiple samples one test at one time. Most popular and versatile analyzers keep sample and reaction carryover to a minimum. Easy operation, good performance. Centrifugal systems. Centrifugal systems apply the centrifugal force for the transport of samples and reagents. The cuvette rotating principle has been reversed, so that the light beam rotates rather than the cuvettes. The first system has been introduced by counter-electronics called dark holes. And its disadvantages are one centrifugal disk usually for one assay, no auto-wash function for compartments in centrifugal disk, and slow speed. And dry systems is used for rapid tests and urgent care center. The light is passed from beneath the support or plastic layer and is directed through the reagent layers. When the light hits the white spreading layer, some of the light reflects back through the reagent layers to a photocell, while some is absorbed. The ISE analyzer principle. Ion selective electrode ISE. Ion selective electrode method. Direct method is applied by SNIPE. This is the next equation. We use this equation to calculate the concentration of the solution. Ionized selective electrode's key part is the selective membrane, which makes it called membrane electrode too. Its main characteristic is only respond to specific ion. Ion selective electrode. The electric potential varies with the measurand activity. Reference electrode. The electric potential is known and constant without being affected by the concentration of the measured solution. To make it more specific, you can use the battery as an analogy. Ion selective electrode, sample and reference electrode constitute a primary cell. After the instrument detects the electric potential difference, EX, the sample concentration can be calculated. Here is how it works. Samples go through the channel, detect the voltage by the electrode, and compare to the voltage of the reference electrode. Here is the structure of an electrode. The key part is the PVC membrane. The membrane is very small, right between the feeding solution and sample channel. You are not allowed to use hard objects to pair it. Based on the above relationship, we can use two calibrators of known concentration to draw a standard curve, and we can calculate an unknown concentration by measuring the potential.